Hello guys. It's again us with our awesome webinar. And today is a pretty special webinar because we have with us Steve Crocker, who is the internet pioneer, founded the ARPA network working group in 1969 and initiated the request for comment series. He also chaired ICANN board from 2011 to 2017. And it's great to have you here, Steve.
Thank you very much. Pleasure to be here.
Absolutely. So we're really going to have an interesting conversation today. And essentially, what we're going to talk today is about the standards for the internet and registration data. So we're going to run through the challenges and opportunities that we have right now, and perhaps find some sort of the common ground, how we can get those things implemented and perhaps presented to a much wider community for the general use. So, Steve, can you give us some information, what it's all about? Why do we need to standardize the internet and registration data?
Well, thank you. Let me share a bit of background on all of this. I'm going to take a few minutes to go far back in history and set the stage for the problems that we're dealing with today. Let's see if the slides work. This is good. So begging your indulgence for just a few minutes, I'll go back 50 years basically. What we find is that both the domain name system and the registration of IP addresses have grown up without a specific plan. So I want to take you back, as I say, 50 years, more than 50 years ago. The internet grew out of the ARPANET. The ARPANET was a research project within the United States to connect research laboratories that were doing advanced research in computer science. And out of that came the basic technology and some of the beginnings of the organization processes that we deal with. And in order to take you back that far, I have to say something about the technology of the day. We're talking about the late 1960s, early to mid 1970s and so forth. We did not have personal computers. We did not have iPhones or anything like that. Computers were predominantly used in a batch mode to keep them busy, but in some areas, particularly the advanced research areas, time-shared systems. These were sort of mainframes that were used to serve multiple terminals and provide the beginnings of interactive computing. And so the nodes on the ARPANET, and I'll show you a picture in a minute, were these time-shared computers, each computer served, say, 30 to 50 people, and then these computers were connected together over the ARPANET. And in order to do those connections, each of those machines had to be given an address on the network. In those days, the addresses were simple, 1, 2, 3, 4, and so forth. I happen to have been a graduate student at UCLA. We were the first node on the ARPANET, and our host number was 1. As simple as that.
Why not? Right.
Yeah. Although the second computer at UCLA was given the number 65 because 6 bits were used for the IMP number, for the router numbers were, and then the high order 2 bits out of an 8-bit number, etc. Those of you who are technically inclined can do the math.
Yeah.
But where we're headed in this conversation is the auxiliary or ancillary information, contact information. Today, in a registration, you have a registrant, you have an admin contact, you have a tech contact. Back in that day, the tech contact, what became the tech contact was the first thing. It was usually a system administrator who knew something about the time-shared system that you could call if there was a problem. And then added shortly thereafter was what has evolved to be the admin contact, somebody who had supervisory responsibility, and you could call if there was an issue with personnel or resources or whatever. So let me give you a picture. Here's what the 1969 ARPANET looked like. 4 nodes. The circles were where the routers were. The rectangles were the computers that were connected to them.
And Steve,
yeah.
well, the 360, 940, are those the so-called IP addresses of those nodes?
No. Thank you for asking. No, those were the model numbers of the computers. So the 360 was an IBM 360.
Oh, right. Okay.
A 360-75 actually, and the 940 at the top of the diagram was a Scientific Data Systems 940, and Sigma 7 was also was from Scientific Data Systems that got purchased by Xerox, and so it became a Xerox Sigma 7. And the PDP-10 was from Digital Equipment Corporation. So all computers from different places. And each of those, they didn't quite fill a room, but you put them in a special room, and you had air conditioning, and you had a false floor for cabling and so forth.
And I imagine those were huge machines, right?
They were pretty big. They weren't the biggest, but they were big enough. The 360-75 was pretty big. And the circles were these routers. Today you can buy the equivalent capability for $10 or $20 off the shelf.
Yeah, it's probably a Raspberry Pi will do the job.
Here's, let's see if I got it. Oh, I didn't put the picture in. Those boxes were about the size of an apartment-sized refrigerator, and they cost $100,000 in 1969, which would translate into at least $500,000 today. And they had very, very limited capability compared to what you can buy today. And this was all before we had Wi-Fi, Ethernet, or anything like that. The lines connecting these computers, connecting these routers, were operated at the enormous speed of 50,000 bits per second, 50 kilobits per second. And that was considered quite fast for the time.
So, actually, we had, I just came back from Internet Measurement Conference, and at the dinner table with a few researchers, we were actually comparing what computing power we have today comparing to the computer power back in 1970s. And basically, it's 100,000 times much more powerful the computer power is today.
I think each iPhone has more computing power than the entire ARPANET all put together.
Yeah, I can imagine. By the way, an interesting question, I always wanted to ask you this. Why, since we are talking about, the first IP addresses and, how the actual World Wide Web was established, why only 4.3 billion IP addresses were introduced? Because I see the correlation between human population, which was 4.5 billion, versus IPv4 addresses 4.3 billion. Tell me that secret.
Well, it's not really a secret. It's just the sort of the way things happen. So on this ARPANET, the addresses were very short. They were 8 bits. And this network was just a single network. He grew cross country in the U.S. Over the next several months, and then the diagrams changed because there were too many to be connected. But compared to today's network, this is like a toy network. You could have this many computers in a room, or certainly in a company or a campus. But this was big time at the time. I'll get to what this slide says in a second. But to answer your question, it was clear pretty quickly that there was going to be other networks, and that those other networks all needed to be interconnected and independently administered. So this is a tricky problem, because how do you have separate networks that are independently administered and financed and maintained and so forth, and yet interact in a way that provides pretty close to seamless interaction across all of them? So that's what made the internet what it is, interconnection of independent networks. And and when that was being worked out, things were still relatively small scale. This was well before it had become commercialized. So the networks that we were talking about were owned by governments or like that. And so the number of computers involved was still measurable in, we went beyond tens to hundreds to thousands. And it came time to pick what the new address size would be. 32 bits looked like it was big enough to cover everything that anybody would ever need. 32 bits is your number of 4.2 or 4.3 billion. And it was just so much larger than anybody could imagine. And they were wrong. They were simply wrong. Now, you don't get to use every number densely. You don't just hand them out one at a time. You hand out blocks of them, and so you use them up quite a bit faster than just the number of computers. But nonetheless, after a while, it became clear. So that was the basis of what's called IPv4 addresses, as you know. So the next time that they faced the problem, it was really very painful, because they couldn't figure a way to make it a compatible upgrade, but they knew that they had to make the addresses much, much bigger. So they made the full jump up to 4 times the length instead of
128 bits, 128 bits,
128. 128 is big enough to count everything in the universe. I think it's pretty big.
It is.
So, but the simple and straightforward answer to your question is that they guessed wrong when they chose 32 bits. They thought it was much bigger than they would ever need, and it was just turned out that the success. This is an example of what I is commonly referred to as a success disaster.
Yeah, true. But I think that if we would look back, nobody actually thought, let's say back in 50s even, that we're gonna have devices like mobile phones. That was like a some sort of a miracle, with that technology, right?
Right.
Which we use every day. So, for example, I would say that what we imagine and what our vision takes us, we probably even haven't dreamt about what we will have next, I would say.
I think that's true. Now, we do have the experience of having guessed wrong enough times to know that when we are making a prediction, we should look carefully at the assumptions behind those predictions. Bill Gates thought that 640 kilobytes was enough on any personal computer. IBM thought that the total market for its original commercial computers was just a handful around the country. Obviously, very off by quite a bit. But now we have a lot of people who are in the business of trying to guess what's happening and imagine, and it's better. But as you say, we have no idea how many surprises there are going to be.
The interesting thing is that actually, what I see right now as a correlation to what IBM initially started, and you mentioned Bill Gates, Microsoft, they also were the pioneers of, personal computing industry. And I would say that in today's industry, there are technologies that are still paving their road to get them implemented within the massive use of humanity. So I think we're definitely going to see this breakthrough. Well, we see a breakthrough in AI, but we're still kind of, wondering, where it's gonna take us. We see, of course, with breakthrough in satellites, in many other things that actually haven't even realized that we're gonna have this. So that's fascinating how actually the technologies started to evolve, and I think that the biggest steroid for those things is actually the internet, what you guys introduced.
In the early days, the focus was on trying to get the technology to work at all, and then the next phase was to get it to work smoothly enough so that it could expand. And the focus was on growing things. And then today, as you touched on, everyone is very conscious of who hasn't yet been connected. How do we connect the last few billion people? Sometimes this problem or this aspect is referred to as the digital divide, those who have it versus those who don't.
Rural areas and stuff, right?
Rural areas and both rural areas within a otherwise well-endowed country, and then many countries that just are early in their development stage or are so remote that it's hard to provide any. But one thing that happens is there's a leapfrog phenomena. So, for example, instead of where countries did not have very robust telephone systems, cellular telephones came in, and they didn't go through the transition from landlines to cell phones. They just went directly to cell phones.
Absolutely. One question for you, which actually also very interesting take. What do you think? Is it a cable or is it a satellite? Which one actually will gonna be more important moving forward in the internet's development?
The answer is yes. It depends. It depends a bit on location. For dense areas, fiber, I think, not so much cable, but fiber.
Yeah, fiber, correct, yes. Yeah, fiber.
But there are plenty of areas where running fiber to every home or even out to a city is difficult, or you have islands in in the Pacific or otherwise. So you need a combination, and I don't follow it closely enough to pay attention to the fine-grained economics, but it's really a question of the combination of the economics and the geography, and to a certain extent where the entrepreneurial focus is on these things. So I think the if we replay your question in 10 years or 20 years, maybe there will be some clarity, but I would expect there'll be a mixture. The on the satellite, one of the most important things is that the original satellites for communication were all very high altitude, geosynchronous, or 20 odd thousand miles above the Earth. And the speed of light, it takes a while to get up and down. So you use a quarter of a second just to move the photons from ground up and back.
Now we have those low orbit satellites.
Now the problem with the attraction for geosynchronous is that the satellite seems to just hang in the air like a fixed thing. When you move down to the low Earth orbits, the distances are much shorter, but the satellites are moving around. Now we have very, very sophisticated steering and antennas that you can track electronically. You don't even have to move the physical pieces. And so, and now instead of putting up a few big satellites in geosync orbit, we have hundreds and thousands of little satellites smaller. They're not little, but they're smaller than the big ones that were up there,
Hmm.
and ever more complex. And so you have pretty sophisticated systems provided. So it's unclear where what will be best served by low Earth satellites and what will be best served by
Hmm.
fiber. And maybe those things evolve over time. So there may be a region which starts out using one technology and moves to the other.
Absolutely. So getting back to our original topic, because I could spend with you, hours and hours talking about those interesting things. Now, coming back to our original topic, so you introduced ARPANET, the then connected, the first network and stuff. What about the DNS?
So a problem, excuse me, essentially related to the same question about the transition from 8-bit addresses to 32-bit addresses to 128-bit addresses. The names that were associated with these sites, and here, this map, you can read some of the names. I guess those are
Hmm.
computers mostly that are shown. Let me see if I can back up those. Well, we use very short names like UCLA and SRI and so forth. But
Hmm.
as the number of computers expanded, it became problematic to generate names and to maintain the tables of them and to transmit those tables to everybody. And that led to the creation of a hierarchical naming system, the domain name system, with the dots between the names. And then the maintenance of those names was then distributed rather than centralized. And that was the beginning, that was the genesis, the origin of the domain name system.
Hmm.
Let me move on to that. So, as I said, the ARPANET was a single network, more computers, each needing name, hierarchical naming structure. The original version had 7 top-level domains plus 1 for each country, and now we have many more top-level domains. But in any case, it's still a hierarchical system.
Hmm.
And then the World Wide Web also came along during this period in the 90s, and everything exploded. And the network was opened up to commercial use, and we have what you see today.
Hmm.
Everybody talks about exponential growth. A feature of exponential growth is that yesterday looks like nothing and tomorrow looks like everything, and it doesn't matter where you're sitting. A year later, everything that was the year before looks like nothing, and it's exploded. So
And talking about, sorry to interrupt you, but this is very, interesting topic that you covered, the geolocation. So for example, currently there are lots of problems kind of identifying the geolocations for, let's say, mobile operators, or even, the same Starlink has an issue to kind of identify themselves where exactly they are. And that's actually, I think, the things that you currently do are kind of sort of should address those type of problems. How would you envision from the geolocational standpoint, if, for example, those that metadata should be covered within those records?
that's an interesting question. Um, the there are 2 things that sort of operate in the opposite directions of each other. The basic design of these networks is to pay less attention to the specific location of things and more to what is the pathway to get from one place to another, the topology of the network. And if you're just looking at how to route packets, for example, from one place to another, national borders and specific geographic location are less important than what is the optimum pathway route from one place to another. And then on the other hand, as you're suggesting, there are some very good reasons why you want to know where things are for both physical reasons and for political reasons. And so you need to add or make sure that you can find out the geographic location. The network technology does not provide, basic network technology does not provide a natural way of pinning down the location exactly. So you have to sort of have to add that as a component of the network design and the reporting of where things are. So you can use GPS, for example, and other techniques to locate things, but it's also possible to mislabel or even deliberately spoof this. And if it's important to know where things are, then that becomes a security issue.
Mm-hmm. And I think that actually, when you, see that, this should be added manually. Well, we have, the WHOIS records, you add the location, you add the geolocation feed to it and stuff like that. But does that mean, as you say, that information can be spoofed, and then at the same time, perhaps some sort of that framework should be introduced where, for example, the network layer would be capable of understanding the geographical locations, because in my opinion, well, when we work with quite a lot of IP addresses ourselves, we see that there is a big struggle for law enforcement agencies and many others, from the commercial standpoint, to kind of understand where exactly that IP address is.
Yeah. The idea of adding into the network layer a requirement to know exactly where everything is raises some questions about, is that the right place to do that? Because it imposes some costs and restrictions. And on the other hand, as we're discussing, it's oftentimes very important to know that information. So you wind up, this actually gets into one of the core points, which I want to move quickly to, that
Absolutely.
you wind up needing information, and when you look what happens in practice, some of the information is accurate, some of it is not, and it's ideally you'd like all accurate information, but even if you don't have accurate information everywhere, it's also helpful to know which information is accurate and which is not, because there may be information which you can depend upon because of various assurances or the way it's built, and others where somebody supplies some data and you don't know whether or not it's accurate enough. And you want to have a little flag that says, that's what I was told, but I don't know whether I trust it, compared to information that may be mechanically generated by trusted processes. And you say, I do trust that because I know how it was created. And that dichotomy about level of accuracy and tagging, providing indications of accuracy, is, I think, one of the things that's emerging as an important concept in other forms of registration data. So now I'm pushing you hard over to the registration data issues here. Let me push on here. So it's after World Wide Web. So you get DNS registration data, which we're talking about. I mentioned that we started with tech and then admin. Today, of course, we have a registrant for the domain name, and the accuracy of that information and what roles the roles of admin and tech contact don't actually have any formal definition anymore. In some settings, some registrars will say the admin contact has this authority and can do something, but it's not uniform across the entire system, of course. and then, as I've said, there's a big question as to how accurate that information is. One of the things that complicates all of this is who should have access to the information. Prior to the General Data Protection Regulation, GDPR, most of this information was wide open. So that's very good if you want to find out what that registration data is. It's problematic if it gets used improperly for abuse, anywhere from spam to harassment to outright fraud. And the counter reaction is that many people said, well, I'm not going to put the real information in there. I'll put in something that just because the blank has to be filled in, but it doesn't really need to be there anyway. So they'll put in fake names, or they'll put in fake addresses, street addresses, or they'll leave out the phone numbers or whatever. And then in reaction to all of this, they have the privacy regulations that are emerging around the world, GDPR being the biggest and best known, but not the only one for sure, that say, hey, look, you should treat registration data as sensitive, particularly if it has personally identifiable information, and just not make that available to everybody for any reason at all, for a limited set of purposes and under certain conditions, and otherwise consider it to be private and not made public.
But that information, for example, the GDPR currently applies to the domain name system.
Yes.
But for example, it's well known, or for example, I can remind our listeners that the IP addresses still have open WHOIS, where you can see all the information, and that was, of course, because of the same law enforcement agencies, so that they would be able to trace out the ultimate user of the IP address. But here is the question to you, and perhaps that's probably my biggest concern that I see. We have WHOIS that is maintained by the humans, and humans usually do not update that WHOIS as well as we want. So, right? So the question to you, how would you say, those records, what mechanism, or what type of framework should be introduced that we would have, the accurate WHOIS?
Yeah, that is a central question. So, the problem starts with exactly what you said. There's humans involved. So we're not going to wind up with an absolutely perfect solution. We can wind up with both an improved solution and one that has the potential for getting incrementally better over time, that it moves in the right direction. One idea, which I've mentioned, is that there can be different ways of determining whether that information is accurate. So, for example, if we're talking about registration data and a person, how do you know that that's the right person? Well, if they show you their driver's license or their passport or whatever, that's better than if they just type in a name and you have no way of knowing, or if there's a way of correlating it with somebody else. So that leads, at least to my way of thinking, to the idea that you can have degrees of accuracy. And there's a somewhat agreed upon scale, very crude, very simple, ranging from take anything that's typed in to the next level up is check to see that it's syntactically correct, that it looks like a name or it looks like a phone number or whatever it's supposed to be. And the level above that, it's much stronger. Use it in an operational sense and see if you get a response. Send email to that address or call that phone number. And then the highest level, the fourth level, is correlate that with other information so that you have high degree of assurance that it's correct. Now, what I haven't said, and purposely haven't said, is what level must you use? That is a policy that will vary from place to place and circumstance to circumstance. What I think would be helpful is in a objective and neutral way, ask that when information is collected, it also be tagged with what level of accuracy or what level of validation really has been applied. And then it becomes a policy and an enforcement and an evolution question as to whether higher degrees of validation should be required over a period of time. But start with a base system in which you simply try to describe what the accuracy level is. And the results might be disappointing, but nonetheless, they would be what the facts are. So if a registrar, for example, just collects whatever's typed in, fine, say just do that, but be upfront. You have to be forthcoming about saying that's what you're doing. And then if authorities or consensus policies or whatever come along and say that's not good enough, that can be sorted out. But start with a base of just describing what is the current practice, and then people can have subsequent discussions about whether that's good enough or not.
Okay, so you still think that actually this should be left for the humans to manage?
Well, there may be situations in which you can automate some of this, which would be great, but there'll be a lot of cases where you can't. So, as I say, rather than take a dogmatic position and say everything should be done in one particular way, to have a somewhat broader perspective and accommodate that things are going to be done in different ways, some of which will be much weaker and some of which will be much stronger, and be accepting of the fact that that's the way it is, and be able to report accurately about that level of information, and then let the social processes evolve over time that push things in one direction or another. It used to be in the early days when you wanted a domain name, you had to show, you had to fax your driver's license, for example. And the cost of buying a domain name back in those days was like $70 a year for 2 years, and this was a couple decades ago.
Yeah.
So the pressure was to make it much less difficult to register a name, much cheaper, and as a consequence, much less accuracy. And now we're trying to find the right balance here.
So coming back to GDPR, this is a gigantic thing to consider. So please expand on that. How do you foresee, the things from the GDPR perspectives?
Excuse me, I apologize for this cough. So GDPR is a very forceful piece of legislation from the EU that puts very high priority on privacy, and was not specific to DNS registration. It applied to everything. The people within the administering domain name registrations took a very, very conservative position and said, oh my goodness, this law is so strong that if we screw up, we're going to lose a fortune because of the size of fines that are involved. And so they took a very stringent position with respect to controlling who could have access to the registration data. The effect was over a very strong reaction that went so far in that direction that, yes, it provided protection on the privacy, but it also close to eliminated, making it available for legitimate purposes and to trustworthy people and so forth. So now we're in a period of trying to find a way to rebalance this. And I've spent a lot of time at ICANN and watched ICANN struggle with this. And I have to say, ICANN's first reaction is, this is a very dangerous area. We don't want to take any risks, so we're just going to leave it to other people to decide what decisions to make. And that, in my view, has not been very helpful because it needs to be sorted out. And I can go on for a long time about that. I had the privilege of serving as the chairman of the board of ICANN, and sitting on the board for a long time, and serving as chairman for 6.5 years, and watching the struggle. And to make a long story short, when I left the board, I decided that this problem needed attention, and I've been spending the last few years working very hard on it, forming a group that could provide interesting ideas. Let me, I'm watching time here, Vicente, so let me move ahead.
Absolutely.
Yeah. So the current status is that ICANN has got a system of not very powerful system, which basically takes requests for registration data and passes them on to registrars and doesn't take any responsibility or help form what those requests should look like or what the answers look like. So my view is that we can do a lot better, and we can do better in a couple of ways. One is a lot of the discussions that have taken place over the past several years have focused around, well, how can you identify who is requesting the information, who the requester is? And how do we know that that identity is accurate? And you go down that path and people start inventing very expensive processes, and all aimed at simply determining who's making the request. My view is that that's both too much and too little. It's too little in the sense that even if you know exactly who's making the request, that doesn't tell you whether or not you can trust them, and it doesn't give you any avenues for dealing with misbehavior, other than to say, I won't deal with you again. And it's too much in the sense of you don't really need to know, in most cases, exactly who somebody is. You need to know whether you can trust them. And that's a different question, which is best addressed by having the person who's making a request be part of some group that can vouch for them, whether it's a company or whether it's a consortium or whether it's a guild. The strong approach is that when somebody is part of a group and is vouched for by that group, if they misbehave, the impact is not only on the person who misbehaved, but also on the group that vouched for him. And that provides a much, much stronger basis for being able to apportion the privilege of making requests versus who's allowed to answer them and so forth, and for what purposes.
So how you would say, those authoritative parties should be? I mean, how they should be assigned to the authoritative parties?
Very good question. And the way you've phrased the question could lead someone to say, well, somebody has to be in charge of authorizing those groups. And
Yep.
my response to that is, well, why don't we come at it the other way? Let the groups organize by themselves, and the question of who authorizes them can be turned around, and you also organize the people who have the data, the registrars typically. I'll call them data holders as a broad term. And you have a bilateral relationship between a requester and a data holder. So a requester makes a request, it goes to the data holder has to decide whether to respond or not. If you have groups of requesters that are put together in the way that I've described, and you have a group of data holders, then you could have a bilateral contract between those two groups. And the challenge, the problem that you're posing gets transformed into the following. a group of requesters, I'll just take as an example, intellectual property attorneys may say, look, our people need access to registration data so that we can track down who's behind particular domain names when we think that there is a potential for abuse, infringing on the intellectual property. So let's imagine that these intellectual property attorneys get together and they say, here's who we are, here's the rules that we operate by, and here is your avenue for dealing with any problems. And we represent to you that we will behave properly, and that if we don't, we'll have a discipline problem and you can deal with it. Then the registrars on the other side can say, can look at that and say, is that strong enough to protect us from recrimination if something screws up? And probably the answer is yes, because it's to everyone's advantage. It's certainly to the requester's advantage, and it's to the data holder's advantage that these things work smoothly enough. They won't be 100%, but they work well enough. And then if there are problems, and somebody starts pointing a finger, say you should not have answered this request and so forth, you say, well, look, here's the processes that we followed and we tried, and here's the action that gets taken if it's discovered that there's some persistent problem. So to pop back to your question of who authorizes these relationships, it becomes the groups of registrars looking at the group of requesters, and the pressure is on the groups of requesters to look like they are trustworthy, to present a very solid case. And those that succeeded doing that will serve as examples to other groups, like say, let's say security practitioners may want access to data, and the registrars may say, you guys are a bunch of hackers, we have no idea who you are and we can't deal with that. And the security practitioners would then be encouraged. I mean, they would see the example and would say, well, look, how about if we have a code of conduct? How about if we have an organization? How about if we have a contract with you and we behave in a way that's comparable to the way the intellectual property attorneys, and bring order to our own house, and you can trust us just as you trust them. I don't know how well that's going to work, but that seems to me far better and far more likely to succeed. And the really strong view that I have is that you don't have to get it all to work at once. You give a worked example, and if it works well, then other people copy the elements of it. And
test and error.
Yeah. And if it doesn't work, then people also pay attention to that and say, well, we won't do that again.
True that, exactly. And those additional things actually representing in your next slide about who's going to vouch for the identity and the other things.
Right. So this slide, I think, is consistent with all the things that I've just said.
Yeah, absolutely. So, talking about the ecosystem, the requestors, the registrars, the internet registries and whatnot, those are the guys that sit on the top level.
Yep.
But if we look at, the lower level, let's say if we take, as some sort of the small telco, I'm giving very kind of, practical examples, where they don't care about the WHOIS information, where they actually, are not that keen on working on those things. And there are many of those companies, that actually do not maintain or not actually even interested in maintaining those WHOIS records. And actually that also happens within the domain systems, within the domain registrars, where the customers are simply not interested in having the updated records. how do you see, let's say, those things applying and kind of, that standard would grow to the, from the top level to a down kind of segments of the internet?
So there are two different aspects of what I'm hearing in your question. Uh, the smaller operators, uh, part of what you're touching on is, do they want to how much work do they have to do to be responsible? And the short answer, it could be outsourced or aggregated. But a different aspect of what you're asking about, I think, is that some of the information that they have might not be all that sensitive, might not be, or they may not have any detailed information. So this provides an opportunity for having different sets of rules depending upon who you are as an operator and what kind of data you have. And uh, you can say, well, look, I have this data, but it's not very sensitive, so I'll just make it available to anybody, or I'll use very lightweight controls as to who gets it, compared to operators that have a massive amount of personal information for which they have to be much more careful. And one of the things that is part of the picture that I'm trying to paint here is that you do not have to have a uniform set of rules. You can have a graduated set of rules depending upon the different parties. I made reference to, you could have a group of requestors and a group of registrars, and they have a contract, and that contract could also specify how much data is going to be made available and how accurate it's supposed to be and so forth. And you might have and the details in each of these contracts could be different. However, the big thing would be to make sure that that information about what's expected and what's required is publicly available so that the people who are engaging in that can formulate their request, meet the requirements, and have an expectation of what they're going to get back.
Mhm. So that's actually, the question was for your next slide, because that's, actually represents, the things, how they should be escalated from the top down the bottom. But, the ultimate question here, since the whole internet is evolving and evolving, so fast that at some point we even don't pay attention, that there are those technologies out there that can definitely be employed. And, for example, perhaps we can do some sort of the centralized ledger where, for example, we could have some sort of the record set of the every single internet resource to kind of identify things. And I'm, referring to the technology like blockchain, but, I truly think that this type of technology can be implemented in the registries, in the some sort of the ledger history, but definitely not for speculation. But I think it's a beautiful technology that actually could probably, give a good kind of, order for the data consistency. What's your take on that?
Blockchains are very elegant, very pretty technology. I think there's an open question as to which things are a very good fit for, and which things look attractive but don't actually provide very much. The negatives for blockchains are that it doesn't scale very well, computationally expensive and so forth. what they do is they provide a way of having publicly available data that can be assured in a very
And
strong way.
validated. Yeah, yeah,
So
yeah.
that's a positive. Um, Longer discussion required. I know that there's a lot of interest in blockchains, a lot of work that's been done on it. Um, my guess is that much of what's needed in the area that we're talking about here doesn't require blockchains and wouldn't be my first choice. Maybe they are for you. Um, it isn't terrible. I mean, one could do things in different ways. But the bigger issues are going to be um, what data is actually collected and who it's made available for, whether or not that is stored in a blockchain or stored in more traditional databases is maybe a layer down, one level down in terms of implementation choices.
Yeah, you see, I noticed your next slide about the centralization, and I thought, perhaps I should ask you, some entry question,
I appreciate it.
that
I appreciate it.
that actually, sometimes I think that in some of the cases, uh, technology is the answer, rather than and basically it helps to maintain the order, but not kind of a routine. Let's put it this way, if you know what I mean. So
Yep.
basically, if you have an order, if you have a system, if you have technology that actually works perfectly, then perhaps that's the way to go. But sure, I understand where you're coming from. From the perspectives of what we are discussing today. So carry on, Steve.
Yeah. So another thing to say about decentralization is that getting everybody to agree on a single system that is operated by one authority is very, very difficult because there's a lot of competing views. The technical views are sometimes problematic, but most often it's the political and financial incentives that lead to big fights or big stalemates in terms of reaching agreement. So, let's imagine trying to get the Chinese to agree on a system and the Russians to agree on a system and the Americans to agree on the same system and use the same set of rules. Um, what is this is 2024. We'll be back here at 2034 and the discussion will still be going on.
Yeah,
Um,
agree.
but if you say, look, we can agree on sort of the underlying technology, and then the policies that you use within that technology can be whatever you decide for your data, and and you make the technology neutral instead of embodying one person's technology or one country's policies versus another. So, in that sense, my sense of the decentralization is that it allows pieces of this overall system to come together and others to come together later or to be built later. And the decentralization has, in some sense, two big positive features. One is, as I said, the different parts can progress at different rates. And the other is that you can have competition in strategies, and some will be more successful than others. And that will allow people to observe what others are doing and either copy or do something else and innovate, rather than trying to have a centralized decision system about how to design this, and then the enormous bottleneck that comes when you centralize the decision making.
That's actually a good point, and I can't agree more on that. Absolutely.
So this is my sort of the summing up of what we've talked about. Incremental activity that moves, in pairwise agreements, but along, and then others observe what's going on. Very similar to the way the internet was built, with separate networks that are independently administered but can all interoperate with each other, and there's no single party that's in charge, and so you don't have the, as I say, the bottlenecks in terms of making decisions, and you don't have the risks of one party being in charge and other people being unhappy with that.
Mm-hmm. So what about the accuracy? How would you foresee the accuracy things?
We were talking about accuracy before because we edged into it in terms of the geolocation question that you asked.
Mm-hmm. Yep.
So I think this is one of the more difficult areas, and the approach which I was suggesting is, let's divide the problem up into two parts. One is, instead of specifying what the accuracy level has to be, and then having to find a way to make that happen, is let's start out and more softly, simply recording and asking everybody who handles the data to record what that accuracy level is based upon what process was used. And if they say, well, we don't have a process, we just take anything that we've given, you say, that's okay, that's what that is, and we'll mark it like that. And then that is the beginning of a feedback loop. And if people find that it's working okay, that's fine. If they more likely discover that all that data is garbage because nobody's providing any accurate data, at least you have the data about the data that tells you that you need to do something about that. And then people can start to say, well, in that case, we better add some verification of the identity.
But then again, identity verification, is it the right approach?
That's a very good question. I'm going to say I don't know.
Well, I would say that in some of the cases, when in our experience, right, when we actually do a KYC for any coming client in our platform, we always see that there are things that you can definitely get around the company or about the individual, even without requesting, the IDs or ID verification and things like that. Because there are so many data sets out there right now that I think combining those and making something available would be a very good choice, or perhaps the option that can be utilized by many others.
Absolutely, and you're making me hungry to run the experiment and get systems that are able to.
Steve, we definitely should do this test.
Yeah.
We definitely should do this test. Steve, before we run, I have two more questions.
Please.
So first question is, looking back at the early days of ARPANET, what were some unexpected challenges that emerged?
I'm laughing because it's one of the questions that I get most often. In the early days when we were building this, we kind of understood that there was a security issue, but it wasn't a very serious one, because if we didn't know everybody who was using the system, we knew people who were in charge of the people who were using the system. And so there was misbehavior. A lot of students would try things out, and you could call up the site that they were coming from and say, you got a problem there, can you go deal with this person? So for that reason and for other related reasons, there wasn't a lot of attention to a high degree of security. That's, of course, emerged as a big, big problem on today's internet. Um, we didn't anticipate that it would grow as quickly as it did. So that led to all sorts of problems. The addressing problem that we talked about much earlier was one of them. The rise of social media, I think, was a pretty big surprise, and the use of social media that displaced credible news sources has been a serious problem. I don't know where that's going to go. I hope we're in a intermediate transitional stage. I don't know how it's going to settle down, but I think that that's certainly something that was bigger than we had focused any attention on. We could see an awful lot, frankly. We could see, the kind of thing we're doing now, conferencing. We could see interpersonal relationships develop. We could see collaborative work. but there's certainly a lot that we couldn't see in the early days. And then as it emerged, the question is, how do you start thinking about it hard enough to keep up with it? And so it's been a fun ride.
Absolutely. And it still is. And still is. The second question, if you could go back and change one technical decision made during ARPANET's development, what would it be and why?
Well, I spent quite a bit of time in the very early days thinking hard about what the protocols should look like, and I was more interested in very flexible, very powerful primitives that could be put together to do different things. We did okay, but we didn't do as good a job as I think we could have if we'd seen a little better. So that's an area. Now that may sound very limited or specific to a particular interest. What other things? Well, the whole issue of everything social media and some ways of dealing with the interplay between children on the one hand, as both as users and as people who might get abused or preyed upon on the one side, and then various forms of crime and negative hacking by not just youngsters, but more organized gangs or even national entities is something that we might have been able to be a little more forceful about. We did try actually to anticipate some of those. It turned out to be much harder than we could do something about, because all the systems that were connected to the network were built by independent companies, and there was no uniformity in the way that they did business. And some of their products were okay, and some of them were not very robust. And there wasn't any way to have strong feedback to that, even when we found problems. So, it was challenging. We could see some of the things that were coming, and we couldn't do much about it except just keep going. And here we are.
Here we are. Indeed. Steve, it's really an honor, for you to be in this webinar, but, all the good things come to the end, and we have to, the time is running up now, and it was really an honor for me to have a webinar with you, talking and sharing of thoughts with you and asking questions, where you had some time to think. I hope, I challenge you a little bit.
Well, I would say more than just a little bit. Very, very good, hard questions. Look, it's been a real pleasure. Thank you for the opportunity. I hope it has been useful, and even if it hasn't been useful, I hope it's been entertaining
Absolutely.
for everybody. And look, you and I will be back in contact very shortly.
Absolutely. Thank you very much, Steve. Have a good times in Dublin.
Yep.
And let's keep on working towards a better internet.
Take care.
Thank you.
Thank you very much.